Okay, we'll do some examples of simplifying radicals that have a coefficient out in front. So here are two more examples, and I'll try to go a little bit quicker this time, maybe explaining it a different way. When I have a coefficient out in front of that square root, I'm leaving it. I'm going to take some time just to simplify this 135. And I'm going to rewrite the 135 so I can simplify it. What perfect square goes into 135. And if you're getting stuck, use your calculator. Take a time. I'm going to use this calculator for a different reason right now, but the square root of, 135 divided by 4, nope, 135 divided by 9, yup, 9 works. So I'm going to write that one down. 1 works, 9 works. And I can keep going. 135 divided by 25, nope. And I can make some educated guesses that I am done, and that 9 is the biggest perfect square that goes in there. And 9 goes in how many times? You can use your calculator to say, okay, well, 135 divided by 9 is 15, so 9 times 15 is 135. Now, what's the reason we picked 9? We like these perfect squares. We want to pick perfect squares because the square root of 9 is technically 3, and the square root of 15 stays the same. At this point, you'd be done. If I said, please simplify the square root of 135, you figure out what perfect square goes in, you simplify it. But we don't want to forget about this number out in front, or this coefficient of 3. So I'm going to bring him down. Don't want to forget about him. Bring this little guy down. 3 square root of 15. And there's a little multiplication symbol that might be a little, it might be invisible because it was up here, but we're going to add it. And then you're going to combine those terms. 3 times 3 is 9 roots of 15. And I'm going to show you something real quick here. I'm going to use a different color. This was our original problem. When I type that into my calculator, I got to go all the way down here. Okay, when I type that in my calculator, 125 or 135, that's not right either. Sorry, you guys, 135. Okay, that's a decimal. Like if I said, okay, find what this is, and you told me it's 35.85, I'd be like, or 34. I'd be like, okay, you're right, but I want it in simplest form. This is what you tell me. Because they are the same thing, just one is simplified. You want that number under the square root to be as small as possible. And so we are simplifying it. They should be the same. Check your answers. You want your original problem to be the same as that second one there. So, or your final simplified version. So let's try one more. -2 square root of 63. All right, we are looking for that square root of 63. We're going to forget about that 2 for a second. The square root of 63. What perfect square goes into that? I'm going to give you a second to think about it. Use your calculator. 63 divided by 4 doesn't work. 63 divided by 9 does. And you can keep going and you'll realize that 9 is the biggest perfect square. So we're going to plug in 9. 9 times what is 63? 9 times 7 is, and what's the square root of 9? That turns into a 3. Okay, so if I said, what's the square root of 63? You'd say it's 3 roots of 7. I'm going to show you that that's true. The square root of 63 is 3 roots of 7. They're the same. We're just simplifying it here. Now don't forget about that -2. So we bring down the -2. I'm messing up my colors here. Bring down your simplified square root of 63. And lastly, you're going to multiply both your coefficients because it originally had a coefficient and now you're adding a coefficient and you multiply those. And if you want to check or you don't trust me or you don't trust yourself while you're working, you can type in the original and type in what you think your answer is, and they should be the same, and you'll know that it's simplified.